Assalamu alaikum. So it is the first video of Amazing Circuit Problem playlist, and in this video you have an infinite circuit and you have to find the equivalent resistance of this infinite circuit. So you might be thinking then R equivalent is also infinity, but it's not true. We will have a finite equivalent circuit, equivalent resistance from this circuit. So in this video we will find equivalent resistance of this circuit and then explain why infinite circuit has finite resistance, and you have a home task at the end. So let's start. Okay, so let me draw a box here, and inside this box let's say that the equivalent resistance inside this box is equal to R equivalent. So I can write R equivalent instead of this part. Okay, now you have to understand what is R equivalent. R equivalent means infinite this type of patterns. Where this patterns comes from, if you observe carefully, you will have these patterns, you will have these patterns, infinite patterns, right? You have infinite this type of patterns, and R equivalent is consist of infinite this type of patterns. So R equivalent means infinite this type of patterns. Now listen to me carefully. Let's say y is equal to 5 plus 5 plus 5 plus, let's say y is equal to infinite 5. Okay, so you can define y as y is consist of infinite 5. Okay, now pick this part and tell me what is this inside this bracket. You will see that you have infinite 5 inside this bracket, right? So you can also say this part is y, right? So this concept is crucial to solve this circuit. Let's proceed and you will understand it more carefully. Okay, now I will draw a box here, and inside this box I again have infinite this type of patterns. I again have this type of patterns infinite times, right? So I can again say that this is R equivalent, because R equivalent means infinite this type of patterns. So instead of this part I can write R equivalent. Okay, now you have two circuits, circuit 1 and circuit 2, and these two circuits are derived from the same circuit, and so we can say that this circuit and these circuits are equal. That means you have two circuits and the equivalent resistance of these two circuits are equal. The equivalent resistance of first circuit is R equivalent simply, and the equivalent resistance of second circuit, these two resistance are in parallel, so 1 by 2 plus 1 by R equivalent, then again take an inverse, and this 2 is in series with this part, so we can plus a 2. And as the equivalent resistance of these two circuits are same, so we have to put a equal sign here. So we can write R equivalent is equal to 2 plus, if you simplify this term you will have 2 into R equivalent, then R equivalent plus 2. Okay, now again simplify the right hand side, so 2 into R equivalent plus 4, then write this to R equivalent, then here R equivalent. Okay, now multiply this thing with this, so I will get R equivalent square plus 2 into R equivalent is equal to 2 R equivalent plus 4 plus 2 R equivalent. Now cancel this 2 R equivalent and rewrite this equation. So you will have R equivalent square, then minus 2 R equivalent, then minus 4 is equal to 0. Now it's simple, you have to solve this equation. So if you solve this equation you will get minus b, then plus minus b square minus 4 into a into c divided by 2 into a. If you simplify this term inside this bracket, you will have 4 plus 4 into 4, and if you take 4 common here, then you will have 4 common, then 1 plus 4. Okay, now root over 4 is equal to 2, so 2 cancels out, and you will have 1 plus minus root over 5. So R equivalent is 1 plus minus root over 5, but you have plus minus here, So R equivalent can be 1 plus root over 5, or R equivalent can be 1 minus root over 5. But equivalent resistance or any resistance cannot be negative, right? That means 1 minus root over 5 is equal to minus 1.23, and this cannot be possible. So R equivalent is 1 plus root over 5, that is equal to 3.23 ohm. So this is the answer. So we have a finite equivalent resistance though our circuit is infinite. So now we will study why R equivalent is finite though we have infinite resistors in our circuit. If you study infinite series, let's say 1 plus 1 by 2 plus 1 by 4 plus 1 by 8 plus 1 by 16, and if you sum up to infinity, observe carefully that half is smaller than 1, again 1 by 4 is again smaller, then 1 by 8, then 1 by 16, and then you might 1 by 32. You will get a smaller number as you proceed to the right hand side, and if and here you have sum of infinite terms. Though you have sum of infinite terms here, you will get a finite result here. So that means the sum of this infinite series is finite, right? The similar things happens here. The effect of this pattern is more, and this pattern is lesser than this, and as you go to the right, as you go far from this battery, the effect will be negligible, the effect will be smaller, and the similar things happen here. As you have a smaller number, you are summing a smaller number as you proceed to the right, so the answer is finite. Similar things happen here. As the effect of this pattern is small, so summing this pattern will have a less impact on the R equivalent, the result of R equivalent, and so we have a finite R equivalent. So at the end of this video, you have a home task. Instead of 2, now you have infinite R, and now you have to find what is R equivalent. You can tell me that in the comment section. Okay, thank you.